All right, boys and girls, welcome back. This is going to be a very difficult 5-minute lesson, meaning to keep all of this into 5 minutes is going to be a challenge, but I'll do as fast as I can. Okay, why? Because there's so much vocabulary. So a point of concurrency is a point where more than one thing meet. Okay, they're concurrent. They meet. So that's going to be, we're going to learn 2 points of concurrencies in this section. One is going to be called the incenter, and the other is going to be called the circumcenter. So the incenter and the circumcenter are types of points of concurrency. Okay. Now, we're going to use these words circumscribed and inscribed. So here I have a triangle that's inscribed. The triangle is inscribed, and the circle, you would say, circumscribes the triangle. So that's how those words are used. Okay. All right, let's move on. All right, so this is kind of what this comes down to. And like if you worked in the high ends for like UPS or FedEx, these types of things are so important for you. So like think about this. A town has 3 recycling sites. They want to build a parking garage for the trucks so that they're equidistant from each site. This is like a real world problem you'd had to try to figure out. And look how difficult this is. If I come down here and mess with this, to figure out how to get this so that all of these are the same, the guess and check is, look, if I just change it a little, it just affects. It's so difficult. So we're going to use a better version, a better mathematical solution to find this. So let's get into that, okay? The perpendicular bisectors of a triangle are concurrent, so they all meet at a single point. And that point is equidistant from the vertices of the triangle. This is important. This is what we were just talking about. So think about what we learned before about the perpendicular bisectors. And so we need to understand this theorem. If D, F, and G are all the perpendicular bisectors of the segments of a triangle, then PB, PA, and PC are all congruent. Okay? So how would we find the best site? Well, we would draw a triangle. I'll just do this, very quickly. Find the perpendicular bisectors. Oh, let's see how these going to line up. There's the midpoint. Yeah, that's pretty good. So this right here, that point, even though we're going to talk about this, even though it's outside of the triangle, it's the same distance from here to here as it is from there to there, as it is from there to there. Okay, these 3 segments would all be the same. So in order to find a point that's equidistant from all 3 vertices, we just simply need to find where the perpendicular bisectors meet. Okay, now where those perpendicular bisectors meet, let's see, does it tell us what this is? Well, we're going to call that the circumcenter. There it is. Okay. So we're going to call this the circumcenter. And after we're done with 3 lessons, I'm going to encourage you to go back and look at this 5.1 to 5.3 video. Okay. All right. So what we've learned so far is that the perpendicular bisectors meet at the circumcenter, and that circumcenter is equidistant from the endpoints or from the vertices of the triangle. Okay? And here is a construction example. All right, now the angle bisectors. The angle bisectors, as we learned before, are equidistant from the sides. So the angle bisectors of the angles of a triangle are concurrent. They meet at a single point, and that point is equidistant from the sides. So what that means is that I could now inscribe a circle. Because look, these are radiuses. It's not supposed to be a sad face, just a circle. And so now look, because they're radii, this, and this are all congruent. So that's what the angle bisectors do. They form three segments that are equidistant from the sides. Let me get off of this. Boink. And here's a cleaner picture down here. Notice that the angle bisectors are always on the inside. And so we call this the in-center. The in-center, okay? Now, if I could just make one more note before I finish this video. For perpendicular bisectors, if the triangle is acute, then the circumcenter will be on the inside. Look, I'll just do it real quick. So there's the in-center, equidistant from the 3 points, okay? If we have our triangle be a right triangle, then the perpendicular bisectors will meet on the triangle. Okay, that's a little high, but just bear with me. And then if the triangle is obtuse, the perpendicular bisectors will meet outside the triangle. Okay? So no, what that's saying is that this point is the same distance from, well, let me change. This distance is the same as this distance is the same as that distance. Okay? So lots to take away from here, lots of vocabulary, lots of things to wrap your heads around. So just practice and let me know when you have questions. Boom.